matrix. That is all, and this is the points. This you can merge and this you can merge. And this is the output, you can say. These three segments. So, initially we had these points and how it has changed, you can see that. Okay. And now I will be changing this point, this 1 and 1. What has happened? So, initial point and final point you see overlapped, and this matrix is called identity matrix. If you, it is a scalar matrix, a scalar multiplication, when we multiply anything with 1, it remains same. So, in matrix what is happening, when we multiply with identity matrix, the matrix do not change, and geometrically you see this, it was 5 and 3 and final output also 5 and 3, but it is a multiplication by 1 0 0 1, and this type of matrix is called identity matrix, and we learned that identity matrix, and this is the effect. Identity matrix do not change the points, points remain same. Now, what will happen if I multiply with 2, you see that it has shifted this x axis towards this, 5 has become 10, and if I make it 2 again, it has changed y axis also 3 to 6. Earlier it has changed to 10 and now 3 has changed to 6, and similarly if I make it 1, it will have some other effect, and this if we make 1, this will having other effect. You see this final point is getting changed. So, you have a free control on every point in the space. Do you understand what I am doing? I have a point, but now I have a matrix also. With that matrix I can take this point anywhere, anywhere I want. With the help of this matrix, I will multiply. So, what is happening in this world, dynamic world, what is happening actually? Changing, and now I have a control, I can change anything. If it is something is at this point, I can able to change it, and this change how easily we can do, just I have to do a matrix multiplication. So, and beauty is that in doing that you can go on adding either 100 points, 1000 points, million points, because your object may not have single point. Suppose this is a duster, if this duster having 8 corner points connected, then connected with some edges, and it will become a duster, is not it. So, it will having suppose 4 and 4 8 points, 8 points connected points. So, 8 points you can put here, and all these points can be changed with this 2 by 2 matrix. It is not required that there is 8 points. So, your transformation matrix should be 8 by 2. Okay. It row can go on increasing, does not matter. So, if it some object is even having 1000 points, I want to translate this entire studio. This entire studio will be having 100 points. 100 points I can put here, but this transformation matrix will be 2 by 2. There is no change. So, I need not bother about this. If I know that points which is make that object, I can change this object with 2 by 2 matrix. This is the thing. So, going back to my presentation, this I am scaling this increasing, and you can play with that, and I will not spend much time here. Here I have shown already this if you go on changing these elements, these values will go on changing. You see this 5, I have changed this 5. Okay. These elements. These elements I am changing, and I am seeing this 5 3 has been changed to 25 3. This 5 3 5 3 it has changed 25 9, like that it to go on changing. Now, this is the observation from the cases. A transformation matrix whose primary diagonal elements non-zero results in scaling in both axes. Means this is the main diagonal, primary diagonal or main diagonal. This is, you see, this matrix having only 4 elements, and that elements also having 2 elements are diagonal elements. So, if you know the diagonal single information you can tell. If diagonal element is other than 1, that means it will scale. Simple, it will increase or decrease. If you multiply this A and D, if it is 2, then it will double. If it is 4, it will be 4 times, or if it is 0.5, it will make it half. So, scaling is so easy, anything you can, because you are engineers, you are continuously you are trying to make something, and you want to see the effect of some force or something, when it force acted, whether it will collapse, when compression, tension, what will happen, all these things you can, how easily you can generate all these things, and one matrix you should, if you learn, you can do able to do all these things. Here I am saying when A and D is equal and greater than 1, then pure enlargement. So, when it will enlarge A and D, if both are 2 and 2, so x and y is proportionately enlarged, and B and C should be 0 in that case, and B and C 0, A less than 1, 0 to 1, and D less than 1, then compression will happen. So, tensile strength, compressive strength, everything, shear, everything you can capture with these things. And then coming to the reflection, what happens? These diagonal elements, if you make this minus 1, then you see this, it is changing the x values to minus negative, it is changing, and this is actually reflection, this is not rotation. Again this reflection and rotation, what is the difference between that? There you see 5 and 3 is coming to minus 5 and 3, and I will explain this difference between reflection and rotation when I will talk about rotation. Okay. Now, you see that if this element, first element I make it minus 1, it reflects through y axis, as is mirroring, mirror is in y axis. So, this vector is changing here. Similarly, if you have any object here with 10, 20, 50 points, this entire object will be reflected here. So, reflection A, if A is minus 1, reflection through y axis occurs, if D is minus 1 and reflection through x axis occurs. So, if this one is minus 1, it is 1, then this will come here, is not it? These all are having symmetry, and all this world, every elements in this world having some symmetry. You have to find it out. Many things you will find that it is randomly generated, but it is not like that. There is some symmetry. You have to find out. Many things it is automatically y is equal to x square. Automatically you know it is a symmetrical with y axis, is not it? And everything is having that, only thing something you know readily and something you have to find out. So, and when A is equal to minus 1, D is equal to minus 1, reflection will occur through origin, it will reflected like that. And off diagonal elements, what the off diagonal elements do? This 5 3, now off diagonal is opposite diagonal, this 5 3, these two elements are off diagonal. You see this called shearing. Shear means some sudden force has applied, so it has been deformed in one axis. So, in that case shear happens. That same thing I have seen, you can see. Here this exercise will do. I have given the hints now. Now, you have to draw yourself and see that what effects 0, 2 and 3, 5 you have to transform, and you have to create this in Excel. Okay? One exercise let us do. First year everybody has to do this mechanical engineering design or machine design, I think, or drawing. Common subject, engineering drawing, engineering graphics. Okay. This subject is required this projection, isometric view, orthogonal views, all this you create, no, that requires projection. So, I am trying to tell you that what I will be covering today, this already we are doing, and when you finish this matrix multiplication, you have to graph it and you have to show it that it is how it has changed. So, Harshita, you speak Bengali? No, बिल्कुल नहीं. Okay, because morning we had a language policy. In this class you can use any language. Okay. So, when finished, raise hand. I think we will stop here. You can do it no at your own pace. At home you will do that, and you should mail me, because I should able to know that your progress, because these are the building blocks to reach in higher level. Without this, I think you cannot reach at a higher level. So, this you definitely do at home at your own time and email me. Okay? I will go ahead, because our time is short. We should learn more than spending practicing here. Okay? Now, next you should learn what is that parallel line, drawing parallel line. Can you draw parallel line by this Excel? Can you draw parallel lines? What is the requirement of parallel line? Your slope should be same, that is all. Okay? So, can you draw no at home? These are the exercises you can write down here, parallel lines. And what will be the intersecting lines whose slope is not same, it is different slope, you will have a intersecting line. So, you should draw this parallel line and intersecting lines, and then apply a matrix multiplication, and then generate a graph of that transform matrix, and you should send it to via email. Okay? This is the exercise. And what is the characteristics of these two, that is more important to know. What is that? Whenever you apply matrix multiplication, it deforms, it changes. I told you no, but one beauty is that when you multiply a parallel line, this parallelism maintained. This is a beautiful observation, parallelism maintained. And what is the importance of that? You see, this is a rectangular things, and it has a different parallel edges. Okay? Now, I am deforming it. So, what I told, I can scale it, I can change its shape, everything I can do, but by doing that, this parallelism never destroyed, parallelism remains actually. This is a beautiful thing, it will get deformed, it can shorten, it can